All right, welcome to the second lesson in our second week. It's 5.3, exploring trig ratios bigger than 90 degrees. Because if you probably noticed, we've only been dealing with degrees that are between 0 and 90, so the 30, 45, 60 degree exact values that we dealt with in 5.2, for instance. But you have to realize that there are degrees that we need to calculate that are bigger than those. And what we do is basically the ones that are multipliers of these, there's a pattern there. So for instance, 30 can give us 120, 45 can give us 135, 60 can give us 120, 30 can give us 150, and so forth. And basically what we're doing is we're reflecting these angles all around the four quadrants. So it's a very important lesson because, again, it's brand new. And I hope that you have printed it or copied it out so that you can follow along, because there's a lot of new terminology in this one as well. So in order for us to be able to multiply and carry forward these answers that we got for our 30, 45, and 60 degree triangles in 5.2, we have to know what it means to be in standard position. So what we have is our x and y axis here. And there, I'll just write x and y here just to keep it straight for you guys. What we start with in standard position is both arms sitting on top of each other like this on the positive x-axis. And what's going to happen is the top arm, which is called the terminal arm, is going to rotate. So it's going to rotate, still stuck at 0, 0, but rotate up. And this is called positive rotation. So as it rotates up, maybe it went, for instance, 30 degrees, 45 degrees, 60 degrees, until it's straight up and down, which would then be 90 degrees. If it kept going, that would be like 120, 135, 150. And then if it's facing the exact opposite way, that would be 180. And then it would keep going into the 240s until it was like 270. And then it would be like 330, 330, yeah, it would be over here, up all the way until about 360 this way. And of course, the full circle is 360. So the purpose of that was to show you that the arm that didn't move, the one that stayed on the bottom like that, was called the initial arm. And it's always on the positive x-axis. The one that did the rotating up, and notice it's always up. So it started here and then it moved like this, like the hands on a clock. That was the terminal arm. Terminal means finishing, so it was the end arm. And what that created was an angle. That angle, we use a Greek letter, theta, most likely. And theta refers to the entire amount of rotation from 0. Also, we might as well indicate that if we haven't moved any, we're at 0 degrees. If the terminal arm is now facing straight up, so facing straight up like that, we've gone 90 degrees. If it's gone all the way now facing the opposite side, we're now at 180 degrees. If it's facing straight down, that's 280 degrees. And if it's gone the whole way around back to its starting position, coterminal with 0 degrees is 360 degrees. So those are important. So we have some words here. This is called standard position. The whole diagram is called standard position. Theta is the amount of rotation from the initial arm to the terminal arm. It's the full angle. Okay, so theta is the full amount of rotation. That is also referred to as the principal angle. Okay. Then we have our initial arm, we have our terminal arm. Notice this was positive rotation. So I'll put a plus sign there. You don't normally put a plus sign there, but just to make sure that it's clear that when you go up, it's positive. If we had started on the initial arm here, but had come down, like the regular clockwise rotation, this would have been negative rotation. So it would have been negative degrees down there. So that's important to notate. And the word coterminal indicates a different amount of rotation, but you end up in the same final spot. So 0 degrees, for instance, matches up with 360 degrees. Those are considered coterminal. So this would be an example of coterminal. 90 degrees matches up. So if we go just a quarter, we are at 90 degrees. But if we go one full rotation plus a quarter, then we've got 90 plus 360. That would be the same as 450 degrees. So 90 is coterminal with 450 degrees. 270 is coterminal with negative 90 degrees. See how they would match up as well? So when we rotate out of the first quadrant, and it's important that you learn how to label your quadrants. So the first quadrant is obviously the one that we're in most of the time. But if we move over here, 90 to 180, we're in quadrant 2. If we're between 180 and 270, we're in quadrant 3, and 270 to 360, we're in quadrant 4. Notice we use the Roman numerals when we indicate those quadrants. So all I'm doing is reiterating these diagrams that you see here on the side. So what if I rotated, I don't know, 150 degrees? So if I asked you to rotate 150 degrees, this is what you would draw me in standard position. You would draw an X and a Y axis, just like we have up there. You can label it X and Y if you want. You would figure that 150 degrees would start here, would pass 90, but wouldn't quite reach 180, right? 180 is too far. So a bit above 180 would put, so there was the initial arm. Our final arm would end up somewhere over there. You don't have to label initial and terminal. We already know what they are. But you would show the rotation with this arrow, just like I showed you up here. The direction of the amount that you've rotated, that's your theta. So that's 150 degrees. But notice, that's your principal angle, remember. But notice we have this little bit of gap, and it's always to the x-axis. This gap that's here, not to the y-axis. We don't care about this. Never ever use this. This is the amount we care about. That little bit extra that we didn't actually get to finish to get to the x-axis, that's referred to as your related acute angle or your reference angle, which we typically use as alpha. So your alpha is your related acute angle. So it's the leftover from theta to get to the x-axis, and always the x-axis. So this guy had one. This guy didn't. He didn't have an alpha. Alpha and theta were the same thing. There was no leftover to get to the x-axis. But over here, because we didn't quite get all the way over, there was a little bit left over. And the little bit left over would be, in this case, 180 minus the 150. So 180 is this line. We know we've gone 150, so this must be 30 degrees. So your alpha in this case is 30 degrees. So what I need you to do right now is to pause, and I want you to draw for me in standard position, labeling theta and alpha as required, 315, 840 degrees, negative 270, and negative 350. Okay, give those all a try, please, and then come back and check your answers. All right, let's see how you did. So 315. Again, you draw an X and a Y axis. You don't have to label X and Y if you don't want to. 315. Well, this is 0, this is 90, this is 180, this is 270, that's 360. So I know I'm going to be in that area. So my terminal arm is going to be in the fourth quadrant, between 270 and 360. I'm going to show alpha. I'm going to show theta, the amount of rotation. Again, starting at 0, curving around till the terminal arm stopped moving. Put your arrow, that's important. If you're not drawing an arrow, it's incorrect. So that you are showing that you have gone positive 315 degrees. That's how you label it. Notice that there's a little bit extra. There's a gap that's left to get to the x-axis. This gap would be whatever 360 is minus 315. And that we know as alpha. So our alpha in this case would be 45 degrees. And that would be how you label it in standard position. So there's your theta, there's your alpha, there's your arrow on your terminal arm, there's your arrow on your rotation. All right, 840 degrees. Now, 840 is obviously a number bigger than 360. It's actually bigger than two 360s. It's positive rotation, so we're going to go up and over and then up and over again. So we're going to go around twice, and then there's going to be leftover. So you need to know what 840 minus 360 minus 360 is. You got to take away two full rotations. So 840 minus 720 is 120 degrees, which means I'm going to be left over with 120 degrees. So minus 360 minus 360 is 120 degrees left over. So how do I show that I've gone around twice with an extra 120 left over? This is how you do it. You go around once, you spiral around that, you go around twice, 120 would land me somewhere in the second quadrant, past 90 but before 180. That's where my terminal arm finished. So again, look at the spiral. Starting at the 0 line, the x-axis, spiral around once, spiral around twice, that's two 360s. There's the extra 120. So in total, I've gone 840 degrees, which is coterminal with 120 degrees. If I had just gone around 120, I would have ended up in the same spot. And you notice that there's again an alpha. So the alpha is whatever remaining right there, the leftover. And the leftover from 120 to get to 180 would be 60 degrees left over in there. All right, let's do negative 270. So the key here was negative degrees. Normally we don't choose negative rotation to label an angle, but if you're ever shown or asked to do a negative rotation, it's important you know how to do it. So here's negative 90, negative 180. Oh, negative 270 takes me right there to the positive 90 degree line. So they are coterminal. Notice there is no alpha. We actually landed on one of the axes. So there is nothing extra left over. So you're done. That's all you can label in this particular case. Versus negative 315. So again, negative rotation means you follow the clock. And we would go negative 90, negative 180, negative 270, little bit extra. Make sure you put your arrow. That is negative 315 degrees. There's a little bit extra here though, left over. There is a related acute angle. And the alpha in this case is going to be whatever was left over to get me to 360 degrees. So 360 minus 315 is 45 degrees. So the related acute angle to that is positive 45 degrees. All right, so that was very, very important that you're able to draw what are called angles in standard position, realizing your principal angle versus your related acute angle, positive rotation versus negative rotation, and how to label the diagrams properly. All right, so we're going to move on to page 2 of the lesson in part 2 of this video.